Assalamu alaikum everyone. Welcome back to the debug channel. If you ever wondered how computers understand numbers or why we use things like binary, octal and hexadecimal, then this video is for you. Today we will break down number systems in the simplest way possible. No confusion, no fear, just logic. Let's get started. What is a number system? A number system is simply a way of representing numbers. Every number system has something called a base, known also a radix. The base tells us how many unique digits we can use. We are all familiar with the decimal number system base 10. Some other number systems that we will work with are binary base 2, octal base 8 and hexadecimal base 16. Examples: decimal base 10, symbols 0 to 9, binary base 2, symbols 0 to 1, octal base 8, symbols 0 to 7, hexadecimal base 16, 0 to 9, and then A to F. Decimal numbers are used by humans, binary numbers are used by computers, octal and hexadecimal numbers are useful to represent long binary numbers in short form. We use decimals in daily life, but computers use binary because hardware can easily understand on and off, which is 1 and 0. So why so many number systems? Computers work with binary, but binary numbers can get really long and messy. That's why octal and hexadecimal exist. They are shorter and easier ways to represent long binary numbers. So think of octal and hexadecimal as shortcuts of for binary. Let's do some counting. Here all the zeros is are same, and then 1 also are same. Then in decimal we write 2, but in binary we write 1 and 0, and but all in octal and hexadecimal we write also 2, and then here is a 3 1 1, and then 3 3 4 1 0 0, and 4 and 4, and then next here in decimal we write 8, and in binary 1 0 0, and octal 1 0, and hexadecimal 8. And most important, in decimal we write 10, but in hexadecimal we write A, and then in decimal we write 11, and then in hexadecimal we write B. 12 is equals to C, 13 is equals to D, 14 is equals to E, and 15 is equals to F. And here is the other some also examples. So bits and bytes. A bit is the smallest unit of data in computing. It can be either 0 or 1. And a byte is made up of 8 bits. You can imagine a bit like a single light switch and a byte like a panel of 8 switches. There are two fundamental digits in the binary system, and one of them is 0 and the other is 1. There is a difference between bit and byte. The base as subscript. What is a base? Here 10 is the base, here 2 is the base, here 8 is the base, here 16 is the base. Conversion among bases. The possibilities. We can convert every type of number system from each another. A closer look at a decimal number. So here, what is a weight? Every digit number has a weight depending on its position. In here, the 9 is in the 0 position as a bit, and 6 is in the 1, and the 2 is in the 2 form. So that's why 9 multiplied by 10 to the power 0, 6 multiplied by 10 to the power 1, and 2 multiplied by 10 to the power 2. And 10 is the base. Binary to decimal. Technique is multiply each bit by 2 to the power n, where n is the weight of the bit. The weight is the position of the bit starting from 0 on the right and add the results. Here, the bit is 0. From in every type of number system, the first bit is equals to 0. So we are doing the we are multiplying with the base and with the weight from the bit, like 1 multiplied by 2 to the power 0, because in this here the 1 is in the first bit and the bit is 0, that's why the weight is 0. And the second one is in the same, the bit is 1, that's why 1 multiplied by 2 to the power 1. Here the base 2 is always same, because why, we are multiplying decimal to binary, that's why. Now we are doing octal to decimal technique. Multiply each bit by 8 to the power n, where n is the weight of the bit, the weight is the position of the bit, and starting from 0 on the right, and add the results. Here is an example. Now we are doing hexadecimal to decimal. The technique is also same, but a little bit difference. What is this? I multiply each bit by 16 to the power n, where n is the weight of the bit and the weight is the position of the bit, and starting from 0 on the right, and add the results. So that's all the same thing. And here a b c, though we have seen that what is a means 10, and what is b means 11, and what is c means 12. That's why 12 to the power c multiplied by 16 to the power 0, that means 16 multiplied by to the power 0 is equals to 1. So 12 multiplied by 1, 16 to the power 1 is equals to 16, that means 11 multiplied by 16, 16 to the power 16 square is equals to 256. That's why a multiplied by 16 square is equals to 10 multiplied by 256. Now we are going to decimal to binary technique. Divide by 2. Why divide by 2? Because when we are doing decimal to converting decimal to another number system, we have to divide by the base. That's why we are dividing by 2. Keep the track of the remainder. First remainder is bit 0, LSB, least significant bit. The second remainder is bit 1. Example, here is an example. You can see like 125 is in the decimal form. Now we are converting to the binary. As you can see, we are dividing by 2. When we are dividing by 2, we can write the remainder as 1, and we can, when there is no remainder, we can write 0. And the result is we have to write from least bit to the most bit. So the result will be 1 1 1 1 1 0 1. Now we're doing decimal to octal, and the technique is divided by 8. Keep the track of the remainder, and this process is same, like we have to divide by 8. The result is 2322. And now we are dividing, where we are converting decimal to hexadecimal. So the technique is also same. We have to multiply, divide by 16, and here is the result is 4d2. Why we are writing d? Because in hexadecimal we know that d means 13. That's why we are writing 4d2. So now we can see that octal to binary, and the technique is convert each octal digit to a 3-bit equivalent binary representation. Here is a 705. So 705, we have seen that 5 in 5, so in decimal, so that's the 101 is in the binary form, and 0 is equals to 0 0 0, and 7 is equals to 1 1 1. And then So the result is here, you can see. And now we are going to see binary to octal, and the technique is group bits in threes and starting on right convert to octal digits. So what is that? Like you have a binary number and you have to convert this to octal. So you have to divide the digits into three parts. Like the first part is have we will have three digits, and the second part will have also three digits, and the third part will also have three digits. So the 111, that means is equals to 7, and 010, that means is equals to 2, 011, that means is equals to 3, and 1 is equals to 1. So the result is 1327. Now we're going to see hexadecimal to binary. So the technique is convert each hexadecimal digit to a 4-bit equivalent binary representation. And the example is 10AF. So we are now going to see, like when we have seen that in decimal the answer, when the 15 is equals to F, and 15 is equals to in binary 1111. So the F, that means, is equals to 1111, and A means 10, that's why the binary is 1010, and the 0 is 0000, and the 1 is 000 and 1. So the answer is here. Now we're going to see binary to hexadecimal. So group bits in 4 starting on right convert to hexadecimal digits. So what is that? Like you have this binary number and you have to convert it to hexadecimal. So you have to divide this, and each part will have 4 bits. So 1101 is equals to b. Why? Because 1101 is equals to 11, and 11 means b. So 1011 is equals to 11, that means it is equals to b, and 10 is equals to 2. So the answer is 2bb. And now we are going to see octal to hexadecimal. So the technique is use binary as an intermediary. So what is that? Like you are going to convert from 8 octal to hexadecimal. So you can do one thing. So you can convert this number to binary first, then you can convert this to hexadecimal. And hexadecimal to octal, the same, the technique is same. So you have to convert this hexadecimal to a binary number, then you can convert this binary number to a octal number. So the answer is 17414. And now conversion exercise, like you can pause the video here and exercise, but I would recommend that try not to use a calculator. And now I'm gonna show the result. So guys, you have understood that actually this is my second video, so you can understand that there are a lot of mistakes in my video. So I hope you will understand and support me, and I will tell everyone that please suggest me how to improve my video and improve the other things. Thank you. Please like, subscribe and share the video. Thank you so much.